because momentarily here we'll be doing some with 13.2, 13.3, but all right. So what we're on the lookout here for is evaluate without using a calculator. In other words, draw yourself a picture. And again, even if we just sketch here, as long as we've got some of the ideas down, that's okay. So here's what we're going to do. I'm going to actually write my steps down here to the left as we're doing them, because this way if you happen to look at something later, you can do this. So number one, all right, we're going to draw our angle. So since it's positive, I know I'm going to be working around counterclockwise. So when I hit 225, so I'm kind of going along here. Okay, here's 180. I'm not going to get all the way to 270. So to get from 180 to 225, I need another 45 degrees. So here's what I'm going to do now. In this particular case, my reference angle is what I have, because here's my terminal side, and to get back to the x-axis is a 45-degree angle. So once I find my reference angle, which in this case is 45 degrees, I'm going to use that to make my special right triangle. So connect this like this. Your triangle always is going to have a side that basically is the x-axis, whether it's on the positive or negative side. Because your reference angle is always going to be right around the origin. So I know this is 90 and that this is going to be 45. So once I get that set, I use my base special right triangle. And for 45, 45, 90, it's 1, 1, square root of 2. So once I've got that info, and actually I did steps 2 and 3 all at the same time, but that's okay. Now I'm going to find my function, and of right now, that's going to be of my reference angle. So when I come over here, I go, okay, so I'm going to be looking for the sine of 45 degrees. And some of you are still going, but I want 225. I understand that, but I've got to use this special right triangle to get there. So I'm going to use the reference angle right now. So the sine of 45 degrees here is opposite over hypotenuse. But I know I can't have a radical in the denominator. So to fix that up, I can just multiply by that radical, and I get the square root of 2 over 2. But some of you are looking over at the answer and saying, yeah, but the answer you have up is negative square root of 2 over 2. You know, what's the deal? Well, let's take a look at a couple of things and just kind of go into reminder mode on a couple of things we talked about yesterday. Yeah, what ends up happening here is my quadrant is my issue. Because if I just went straight to the calculator, I'd be like, okay, so sine of 45, which is what I just did. You're like, ooh, what? Okay, that's the square root of 2 over 2 as a decimal. Once you start playing with these, you start recognizing that a little bit more. If I do the sine of 225, okay, I get the negative version of that. You're like, well, if they're reference angles, why am I not getting the same thing? Because remember, the other thing we talked about yesterday is figuring out what quadrants our particular trig functions are positive in. And since it's Ryan's, I'm going to use Ryan's saying on this. All stores take cash. Okay, and that's sensible. That's something you can actually remember. That's even better than the calculus one. So when I look at this, my triangle is here in the third quadrant. Well, in the third quadrant, only tangent functions are positive. Sine is definitely not tangent, so that's where the negative portion's coming in for this. And that's why I need to understand this to make sure my answers are correct. And that basically is going to be it. And then we just got done checking our sine based on the quadrant. So when you're going through these and you're literally having to use a right triangle to figure out how these work, and you'd be amazed if we were to spend like 3 weeks just doing this stuff, which is like what you would do in regular trig, how you'd just be snapping these off. You'd know 0.70 square root of 2 over 2. It gets to be kind of fun. Oh yeah. 56. Now, the big difference here, when I get to 56, and let me do this because I want to keep my directions here. All right, so I'm going to do one of these. So if we're going to do 56, the only difference here now is going to be I'm starting in radians. Okay, let's turn it into degrees. That'll make this easier to work with. So replace your pi with 180, or you can do times 180 over pi, which would end up being 900 over 3. So this is the cosine of 300 degrees. So, all right, here we go. Get my little grid drawn in here. So 300, it's positive. So I'm going to go counterclockwise. So 90, 180, 270, and I need another 30. Okay, so here's my 300. I've got 30 in here, but remember, I can't make this my right triangle because it always bases off of the x-axis. Your reference angle, which is how far it is to get from my terminal side back to the axis, is 60, and that's where I'm making my triangle. So different from the last one where my terminal angle, my coterminal angle, back on 50, my coterminal angle actually was the angle I was working with because it was right up against the x-axis. Now with 56, okay, I had to find my coterminal and then build from it. But notice one of my sides is right on the x-axis, and it always will be. So I start to look at this, and I'm like, okay, I drew my angle. My reference angle, in this case, will be the cosine of 60. Whatever angle it takes to get back to the x-axis is what I'm going to be basing this off of. So once I have that, and I've made my special right, so I've got 1, my long leg is the square root of 3, and my hypotenuse is 2. I'm looking for the cosine of 60, the cosine of this angle, of my coterminal. So that would be adjacent over hypotenuse. And then to decide if it's going to be positive or negative, I refer myself back to this. And since my triangle's in the fourth quadrant cosine is positive. So I've got the right answer. If I wanted to double check, again, there's nothing wrong with double checking. The problem becomes when we just depend on this. If I typed in the cosine of 300, 1/2, okay? It's like having a quick check right there. It's like having the answers. But that's the process you've got to run through on these. Draw your angle, find the reference angle, again, going back to the x-axis, and then find your special right, trust that, and then use our little form here to figure out what sign it's going to be. right, something, anything else out of the 46 to 56 range that is causing a problem? You're like, nope, that's the only thing that's bad. The only other thing I would mention is, for instance, if some of you are still getting stuck like on 46 or 52, remember, if it's a negative angle, you're still starting from the x-axis, but you're going clockwise. Because if you still go counterclockwise, you won't get the right angle, and you definitely won't get the right sign. So as long as you're careful with that, shouldn't be anything too bad there. Issues, issues, issues.
No, I got a quick question.
Okay.
Triangles, so the x, that would be A, and then the y would be O.
Yes. All right, let's do this then. Move this out of the way. I'm just going to do one in each of the sections just to make sure things are going okay. First section you're going to love, if you haven't gotten there in a little bit already. Tell whether the given angles are coterminal. In other words, can I plus or minus 360 to get to the other angle? If I can, it's coterminal. If I can't, it's not.
First one is.
So yeah, here, 40 plus 360 would be 400.
No, you don't have to show any word.
What's that? 4. Well, let's see. 35 to negative 135. So it looks like it would be the minus on this one. Is 135 minus 360 get me negative 135?
No.
Nope.
Can you have one that, no, you can't have one.
Yeah, it's going to be you either can
yes or
one
no.
direction or you can't. Yep.
It started out as a good question.
He goes, it started out as a good question. So let's see here. In 11 to 18, point P is on the terminal side of angle theta, which is in standard position. Draw theta with theta positive and calculate the sine, cosine, and tangent ratios for angle theta. Okay. So I'm not accused of taking the easy way out. Let's see which one to do. Let's do 15. Okay, so I need to plot my point, and again, we're just being general here. Because some of you look at 14 and go, I can't get to 40, just general. As long as I know what quadrant we're in, we'll be fine. So negative 3, 3 would be somewhere in the second quadrant. So we have got to figure out, when I go to put in my triangles, if I even want to go this route, what I'm basically doing is making sure one of my sides is on the x-axis. That's how I determined which direction I was going here. There'd be my right angle. And again, if I'm looking at the picture, I'd label my x with the x value, my y with the y, and then I'd go ahead and use the Pythagorean theorem to figure out what r is, or what my hypotenuse is. So for instance here, exactly. But if you get a decimal, we don't like decimals. No. Ooh, it's a flashback. Square root of 18 broken down. 3 square root of 2. Because again, when you're looking to break it down, it's what's a perfect square that's a factor? It'd be 9 and 2, so I can get 3 square root of 2. So now, at this point, I can do this either way. If some of you are like, well, I thought we had that AOR thing before, why do I even need to draw the picture? You don't, okay? If you get here, and here's my theta, and you want to use that to figure out your 3 trig functions, I have no issue with that. So if you're going the picture route, and you've got your theta, which again is always going to be attached to the origin basically, okay, I'd have opposite over hypotenuse. You're like, oh great. Here goes the stuff with the radicals. But just remind yourself, the only part you have to tweak is the radical part. Okay, the 3, that's fine. I don't care. Somebody will notice something here in a minute. I'm just going to wait for it. So this becomes 2. So 3 times 2 would be 6. Yeah, these, remember, if they're outside the radical, I can reduce with those. Square root of 2 over 3. No, Brian. No, Hardy. No, square root of 2 over 2. Now, somebody may notice, if they haven't yet, they probably would soon. When you're way back here at the start of this, for some of you that are always looking for a way to save yourself some time and energy, let's think about this for a second. Yeah, right here, I can take care of those right off the bat, and then most of you at this point mentally could multiply by the square root of 2 over 2 and get the same thing. Again, if you're very into, I want to do the exact same thing every time, do this, okay? Because I don't want things getting messed up for you. But if you're one of those, you're always looking for that little way to cut a little something here and there and it makes sense, go ahead and do that. So then cosine. Now I would hope you would notice here, what's the only difference between sine and cosine? Cosine's negative. So what's the answer going to be? Negative square root of 2 over 2. Don't go through all the work again. That's kind of silly. If it's set up the exact same way except for a sign, then just go to the answer except with a different sign. And then tangents opposite over adjacent, which would be -1. Now again, some of you are saying there's a lot to this. Is there a shorter way? Well, yeah. Because we talked about the option of saying, oh yeah, my x value is my adjacent every time with these. My y value is my opposite. And my r value is my hypotenuse. Because then when I went to do the trig functions, it's just opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So, and that's absolutely a legitimate way of doing this. So if you're not a big fan of the picture because you draw them and then things get in the wrong place and it gets messed up, that's okay. Go ahead and just do it with that as your option and roll with it. So that'll work. Thank you. That'll work, you know, for any of those in 11 through 14. But you are, no matter which way you go, you are going to have to calculate your r value. That's the one thing you do have to do. Okay. Oh, what else we got here? Find the remaining trig functions of angle theta. Assume theta is positive and in standard position. Okay. Let's see here. I am going to draw pictures, I think, here. Because this is one of those situations, there's a lot of information here. So let's see, sine is 3 over 5. So my opposite is 3. My hypotenuse is 5. And I've got to find all of these. So I need to figure out what adjacent is. One very simple way to do that. Do I have to draw a picture? No. If you have a right triangle and you know the hypotenuse in one of the legs, how do you find the other leg? Yeah, you're using the Pythagorean theorem. So in this case, since I have the hypotenuse squared minus leg squared is going to give me my adjacent side squared. So 25 minus 9 is 16. So my adjacent side is going to be 4. And once I figure that out, I can start running with it. Now here's kind of the catch on this one. All right, so I already got sine. And we're finding all of them. So we want sine, cosine, tangent, cosecant, secant, and cotangent. I can find all my basic trig functions now. What's my cosine going to be? 4 over 5. Adjacent over hypotenuse. Tangent. Opposite over adjacent. And then these guys are just inverses. They're like, oh, Hardy, you let yourself off easy. What the heck?
So is tangent going to be 1 over 1 then?
So let's say that we end up, and then we end up at 17. Now, this is going to get a little more complicated. Because tangent, I know if they say 1 is really 1 over 1. And I start to think about that for a minute. And I'm like, Here's why I would draw a picture. Because some of you are like, well, why do I need to draw a picture? Because I know opposite is 1. Tangent's opposite over adjacent. So I know adjacent's 1. So why am I worried about this? Why would I not just... Well, there's a couple of things working here that are a little bit scary. The other thing's going to be, so you're like, okay, 1 squared plus 1 squared equals my hypotenuse squared. So my hypotenuse is going to be the square root of 2. And you're like, okay. So again, what's the problem? Oh, bless you. This is my issue. Because I can't just go rolling through this time. Okay, if I paid no attention to the fact of what that said, this would be very, very simple. But there's one little part of this that's going to make life a little more interesting. So let's ignore this for a minute. Let's try and figure these out. So what's my sine going to be? Okay, it's 1 over square root of 2, but we know that's bad news. So I multiply by the square root of 2 over 2. Well, by the square root of 2 over the square root of 2 and get the square root of 2 over 2. Okay.
You know what I meant.
I did.
So then you got to do this, so is that going to be the same thing for the...
So then cosine is actually the exact same thing because it's adjacent over hypotenuse. So it'd be the square root of 2 over 2. And then tangent is, well, 1 over 1. We knew that already. So then when I go to flip these, well, cotangent, that's easy. That's just 1 over 1. Remember, when you get to secant and cosecant, don't use your new one because then you're going to have to mess with it again. If I flip my original, which is 1 over the square root of 2, it'd be the square root of 2 over 1, or the square root of 2. But here's where the small complexity comes in. Okay, theta is not in quadrant 1. You're like, well, what does that mean? Okay, so all students take calculus. If my tangent's positive, but it's not in quadrant 1 where they're all positive, what quadrant are we working in? We're working in quadrant 3 then. In quadrant 3, if you're not tangent, you're negative. So now I have to go back and say, okay, anything that's not tangent has to take a negative. So there's that one added little extra bit besides just knowing opposite, adjacent, and hypotenuse. I can still get all my trig functions that way, but I have to watch to see what the signs are going to be. I have to pay attention to that last little thing that's in there to make sure that my signs are okay. So that's why I wanted to make sure we did one where that happened, so you're not sitting there going, wait a minute, what? So still find whatever side's missing, and then just kind of work it that way. Right, to the back. Oh, they're all back here. And just a reminder again. Just a reminder. 19. Goodbye. Do 18. Okay. Let's see here. Cotangent's 5 over 12. What sides do I have with cotangent?
Adjacent over opposite.
Okay, adjacent over opposite. So, my adjacent is 5. My opposite is 12. And cosine is opposite over hypotenuse. So my hypotenuse is 13. Well, that was nice of them. They actually gave me all 3 sides to work with. So here's how I'm going to handle this. I'm going to go ahead. I'm going to get my trig functions ready to go here. I'm going to go ahead and calculate them, not paying any attention to my sign for a minute. So let's see. I know the cotangent's 5/12. I know cosine is negative 5 over 13. So right off the bat, I know 2 of these. Secant will be negative 13 over 5, because they're just inverses. Tangent will just be 12 over 5, because they're inverses. Right, cosine was negative 5 over 13. Yep. So then, what's my sign going to be for now? 12 over 13. And cosecant would be 13 over 12. But now let's think about this. My cotangent was positive. My cosine was negative. Which quadrant am I in? 3. I can look to see where things are positive. If I see multiple things that are positive, I know I'm in quadrant 1. But if I see one positive and one negative, find that one that's positive. That's the quadrant you're in. Again, if you're not tangent, you're negative. So you've got to use the info that you're given to figure out where this is coming from. Okay. So this we'll talk about first thing tomorrow. Then we'll jump into the quiz preview, kind of go back over all this stuff one more time. And then Monday when you come in, have your note card ready, one side, ready with anything you want.
Not 2 sides.
We'll no.
Can you type on it?
Not 2 sides. Anything you want to do on one side of the note card. Anything you want to do. I'm not going to give you ideas on what to do. I know something I used to do when I was doing this, but I'm not going to tell somebody that. Oh wait, why am I still recording?